Good day guys, welcome to my channel. My name is Rodri.
In a previous video, I demonstrated how to create your first plugin for AutoCAD. If you have not watched that video, please follow the link in the description. In this video, we will focus on extending the functionalities of this plugin. I have created this 3D wardrobe in AutoCAD and I want to create the cutting list for the model. Doing it manually will be time consuming if this will be a routine task, but it's okay if it's only a once-off task. The code will traverse all the elements of the wardrobe, calculate the dimensions, extract the layer and materials, calculate the quantities of each element in the model, and the result will be displayed in the table in AutoCAD. You got the length, the width, the height, the layer, the material, and the count of each element in the model. We need to create a public method called cutting list. We also need to add the command method attribute. This will allow us to call our method from the command line in AutoCAD. This will be the shortcut for our method in AutoCAD. Let's call this CL for cutting list. In the command line, once you tap CL, it will invoke this method. Let's define a variable to hold the current AutoCAD document. We call it doc. We also need to create a variable for the editor, and we also need to create a variable for the database. This will be the document database, because the purpose of our plugin will be to select so we need to select all the elements of the model in AutoCAD. It can be done in two ways. You can either allow the user to pick the elements, to select the element on screen, or to select the element automatically from within the code, so that the user doesn't have to do anything on screen. We are going to go with the second options, so we won't allow the user to select anything on screen. We will do it in the code. For that, let's create a variable to hold our selections. We are selecting all. We need to look through the selection set and check each element, get its information and store in the dictionary. Then we are going to display the content of dictionary in the table in AutoCAD. We need to create a dictionary variable. We need to create a dictionary variable to hold our final result. The dictionary will take a string as a key and a list of staples as the value. The tuple will hold the three dimensions of each element, like the length, the width, and the height. Now we need to do a for loop on the selections. We need to do a for loop on the selection set. Let's define a variable for the string, which will be used as a key in our dictionary. Now we must get each object in the selection set and query its information. We need to create another method, because otherwise this method will be very long and it's not a good practice. Let's create another private method which will help us to get all those informations that we require from each element. This method must return a tuple. Let's call it, we can call it get info. It will take as a parameter the object ID and the string key that we define. It will be a reference because the value will be assigned in this method. In this method, because we will be accessing the database to get the information of the particular object, let's create a using block for the transactions. Must start the transactions because you must always access the database in the transaction blocks. Get the element ID, database, transaction manager, and let's get the object. We open the object for it. We just want to read the information. We won't be modifying this object. Let's check if the object is not null. Let's also make sure that this object is a 3D solid. We must pass it to this variable. Now let's get the bounding box of that element. We now need to calculate the dimensions that we require, the length, the width, and the height or the thickness. And I also want to point out that the dimension you calculate from this result may not match what you expect from your elements. Let's explain what I am trying to. Let's go back to our element, to our cupboard. What I mean is, for this particular, let's take this element, right? If I take this element, you will see that for this particular element, the length for me will be on the x-axis, right? And the height will be, we can take it as a thickness, will be on the z-axis, and the width will be on the y-axis. So for this particular element, this will be the width, and this is the length, and this will be the thickness. It will match our calculations. But if I take this element for instance, you will see that the length, according to my drawing, the length will be on the z-axis, right? And the width will be on the y-axis, and the thickness will be on the x-axis. So it will be a bit confusing at the end, but you need to rearrange to match your details. But for my wardrobe, I will arrange it through the code later on, but I will show you the two ways. So let's calculate the length. Double will be, let's get the extend max point, getting the max point of the bounding box of the extend 3D, and we take the x minus extend minimum point, and we get the x coordinate, and we'll do the same for the width. This will be y and y coordinate. So basically these are the three dimensions we want to query for each element. Let's create a tuple, and this will be tuple create. We must populate it with our 3 dimensions like this. You also need to assign the string value. Remember the string key. This key must be unique because it will be the key for a dictionary, and there cannot be a duplicate. Okay, so to make a unit, let's do this. It will be a combination of the 3 dimensions of the elements together with the layers and the material of each element, right? So that each element having the same key will be grouped on the list, right? Remember, our dictionary contains a list, or this dictionary is contain a list, right? So each element with the same key will be on this list, will be in this list, so that this will help us at the end to know how many elements got the same key. This will help us to count the number of each element, like in this table, right? So let's build our key, our string key. This will be the length. Let's make it this will be the format of the dimensions. So I'm formatting it to 2 decimal places after the comma, yes. And I will also, this will be the width, and this will be the height, and also need the layer, and also the material. So this is our string key, which we are going to use for a dictionary. Remember, because this is a reference, this value will be passed to this one, to this key, so that we can use it in our dictionary. Okay, so this method is done. Let's close the transaction. This command will close the transactions, and we can return our calculated tuple. This must be defined on top here. Like so, and we can now return our dim. Just like that, this method is done, and we can now call this method. We get element info, and we need to pass in the element. This will be the result, and we need to get the element object ID, and we must pass in our key, just like this. The value will be assigned in this code as we did at the bottom here. Before we continue, we need to confirm that the key is not null, because if the key is null, the dimension variable will also be null, and there will be no need to proceed. So let's do this, and let's also check that our dictionary, let's check if our dictionary contains this key already. To do that, contains key, we must check not contains, it must be this way. And if it doesn't contain this key, let's add the key. If our dictionary doesn't contain this key, we must add the key in the dictionary with a new list value. So we are going to add a new item in the dictionary. So we are going to add this key with a new list value. So the value of this key will be a new list with a tuple, and this list will hold all the items with the same key. All the elements in the model with the same key, right? So we first check if it doesn't contain that key, we must add this key, and at that key position we are going to create a new list as the value. And at the bottom, we must now, at this key position, we must add the element information is our dims variable. So once we have this dictionary populated, we need to display the information in AutoCAD in a table. And for that, we are going to create a new method to do that first. Our dictionary is now populated with the element information. We need to create a table in AutoCAD and populate it with the data in the dictionary. And to do this task, we are going to create a new private method that will be responsible for displaying the dictionary data in the table in AutoCAD. So private void, we will call this create cutting list, and it will take as a parameter the database and our dictionary. Create that this, and because we are going to be accessing the database, we also need to create a using block for a transaction, because all the database interaction must happen within a transaction. Let's get the block table, get object, we also need to get the block table record, open for write, because we are going to be creating a table, so we are going to be modifying the block table record. Let's create a table. Assign our table star to the database table star. We must now set the size of the table. This means the number of rows and the number of columns. The number of rows will be the number of elements in our dictionary plus 1. This will be the 1 is for the header, and the number of column is 6, because we are going to be showing these informations: the length, the width, the height, the layer, the material, and the count column, which will be the number of each element in our model. We must add the header row. It will be at row 0, column 0 for the first column. The first column will be for the length, and the second will be for the width. The third column will be for the height, and the fourth column will be for the layer, and the fifth column will be for and this will be the fifth column, which will be for the material, and the last column will be the count column. Let's check if this, but sometimes I don't know why, but we must investigate that. The first row always come like a merge row. So if I leave it this way, it will only show us the first column, and this will be, it will only show the first column. It will be a merge row, and it will only show the first column. So to avoid that, we must first check that his column is not merged. The first row is not merged. Is merge has value. If it is merged, you must just unmerge. You must unmerge this column like that. We must now do a for loop on the dictionary, in our dictionary, to populate the table. To do this, for each element in our dictionary, we must get the string. The key is a string, and this string, remember we created this string earlier. It basically contains all the information that we require. Okay, so we must just get the string key, which should be item key. We must split it. We must split the key. This will be split. The separator is comma. The separator is comma here, so we must use that separator. After splitting the string keys, we must now extract the value to populate the table row. Let's get the length. The length will be key. The first value, the length is at the first index. As you can see here, in our string key, the length is the first value. So we must get the length, and we must get the width and the height. We must also get the layer and the material and the count. We are going to get it from the item. The count, the number of items in our element will be the number of items in the list. So this will be the value count. Alright, this will be the value count. So we must pass this value to the table row, and let's create a variable for the row index. This row index will start from 1 because 0 is occupied by the header, so it must start from 1, and this will be row index column 0. Row column with index 0 will be, let's get the text string. This will be the length. Let's just copy this. This will be the width, and this will be the layer, and this is the column we use for the material, and the last column will be for the count to string, like that. So the row is populated, the table row is populated. We must just increase the row index parameter by 1 each time the row is created. After cycling through all the elements and populate the table, we must now we must first do something. I want to set the table column width. This will be the cells. Now this will be column 0. Width will be 30. This is up to you, depending on your requirements. You can set a column width to suit your need. I will copy this and paste below, and this will be and for the fourth column will be for the layer. Let's make it a bit bigger, and this will be for the material. Let's also make it bigger. and the count, you can leave it 30. So we must add this table now to our table row record. So we must add the table to our block table record. Alright. Append and transaction, add newly created object, that will be our table. Add we must this boolean parameter to true to say this must be added to our database. And let's set the position, the initial position of our table. I will set this one static, but you can create a prompt to ask the user to select the position on the in AutoCAD. But for this one, I will just I'm going to 0.3D position 00. So, and we must generate a table, generate layout, and the table we created, you must close the transactions. We must now close the transaction because we have done interacting with the database. We can close transaction to say we're done. So that's it for this method, and we must call this method here. We must pass in our database and the dictionary, and all will be good. That's it. Let's build this plugin. Let's build our solutions. It built successfully. So let's try the application in AutoCAD. Let's first delete this table, and we must load our application into AutoCAD using the command net load. We must then navigate to the directory of our plugin. This is a plugin this is the DL that we must load into AutoCAD. Is loaded into AutoCAD. Then let's call our command to execute to create the table. Here we go. Everything was fine with all the dimensions and with all the informations, the length, the width, the height, the layer, the material, and the count of all the elements of our model. It also shows you the number of elements, the number of each element in the model. Okay, so that's fine. Maybe in the next video I will show you how you can export this table to Excel.